Welcome back to my channel. Today we're talking about separation of mixtures. When a compound is combined with two or more components that are kind of physically or chemically mixed together, it becomes a mixture. And also remember that these compounds that are mixed together, or these components that are mixed together, are pure. And so they can also exhibit or retain their chemical properties individually. And mixtures are not inherently bad, but it depends on the composition that they are being mixed together. The world exists in mixtures. You can talk of the flowers out there, is a property of mixtures. But the point becomes the composition at which they mix together. That is where the issue lies. Now look at when you mix your water with salt. You know, when you have a good proportion of this mixture, it doesn't really come out that bad. But when there is a difference in the proportion, it becomes an issue. And most of these chemicals, most of these components, you know, that kind of mix together to bring out to exhibit, to become mixtures. You know, most of these components that mix together to form mixtures exhibit their chemical properties individually. And sometimes these components, these components most of the times have an impure substances that that are kind of surrounding them, and also for us to have these single components, there is need for us to separate in order to segment each of these components for them to actually exhibit their normal chemical properties. You can talk of gold. Gold is a mixture of carbon and other impurities. And so these impurities, we call them impurities because they don't really have value. They becomes impurity or impurities because they don't have value. But gold itself, after refining it, has value. And so mixtures are not inherently bad, but depends on the proportion at which they combine. Yes. And so mixtures are kind of divided into two. We have, if mixtures are of the same state, or if they are kind of uniform, they are called homogeneous mixtures. But if they are of different states, or they are kind of uniform, they become heterogeneous. And in this video, we'll be able to separate these mixtures to their respective components. For the procedure, in this experiment, we'll be given sample A and sample B. Sample A comprises your sodium chloride and calcium carbonate. Sodium chloride is soluble in water, calcium chloride is insoluble in water. And how are you going to carry out the experiment? Number one, you have to weigh the empty conical flask. Then you have to weigh 3 grams of sample A and add 20 ml of water. And after that, you have to stir it properly to make sure that both components dissolves. Then after, you use your filter paper and filter your solution. Now for filtration, you have your residue, then you have your filtrate. I will show that with a diagram also. The filtrate is the one that passes through the funnel, while the residue is the one that is kind of on the funnel, with your filter paper, those ones on the filter paper. Now separate the filtrates and residue. For sample A, you have to discard the residue, the one at the filter paper, and after that after weighing, you subject the filtrates to heat. Now after subjecting this to heat, then you have to this is with your conical flask. Then after you have heated it and the water evaporates, then you weigh your cold conical flask with the recovered salt, because eventually this is evaporation to dryness. There must be salt there. Then you get the mass of the recovered salt. So I will also tell you how to recover your salt when I'm proceeding to the table. Okay, now for sample B, you have calcium carbonate and unknown, and the reagent you'll be using there is hydrochloric acid, while the reagent here is, or the solvent here, is water. For here you are using hydrochloric, hydrochloric acid. So you weigh your filter paper now. Sample A, you weighed conical flax. Sample B, you're weighing filter paper. Then you weigh 3 grams of sample B. Then add 20 mils of hydrochloric acid. Then you filter the solution. Now, once you add the 20 ml of hydrochloric acid, you have to wait for a bit and allow your sample to kind of dissolve. But not really actually dissolving. You just have to. The essence of the sulfuric acid is to help to dissolve your calcium carbonate, and also to dissolve some of the organic components that are found in your known sample. Okay, now you discard the filtrate. Sample A, you're discarding the residue. For sample B, you're discarding the filtrate. Okay, as I mentioned earlier on, the filtrate is the one that has passed through the funnel. Then with the aid of evaporating this, you subject this to heat, to dryness. You'll be using oven to dry this. And after that, you have to allow it to cool for 5 to 10 minutes. Then you weigh the dried residue. Remember, the dry residue is together with your filter paper. Also, you have known the weight of the filter paper already, and now you're weighing the filter paper together with your dried residue. Then with that, you can determine the mass of the residue, by doing some calculations. And after that, you have to rinse all your apparatus and return them to their appropriate position. Then for the diagram, this is just a diagram of what you'll be seeing. Now, this diagram, this is your conical flax, this is funnel, okay, I couldn't label that, sorry about that. Then this is filtrate. Now, filtrate is what you're using for sample A. Then while the residue, the one here, leftovers in your funnel or in your filter paper, is what you'll be using for sample B. Okay, let's head down to how you're going to present your result. So this is how you are going to present your result for sample A and sample B. You have 2 columns. One will be for sample, one will be for the weight. And remember, it must be in 2 decimal places, and you must put your grams. Now you have weight of conical flax. You record weight of conical flax here. Let's assume weight of conical flax is about 120 grams. Now the weight of conical flax from your filtrate after you have filtered, let's say you have about 140 grams. Now for you to get the mass of your filtrate, it becomes 140. That's line 2 minus 120 grams. So whatever that gives you becomes the mass of filtrate. Then have mass of flax plus filtrate. This is after filtration. Of course, there should be evaporation, and the weight of the sample or the filtrate will reduce, and that becomes your weight. Now, mass of the recovered salt becomes line 4 minus line 1. So once you subtract the weight of conical flax from the weight of the mass of flax plus filtrate after evaporation, that gives you the mass of the salt. Now for sample B, you have this table also. We have the weight of filter paper, the weight of filter paper plus the residue after drying, then the mass of the residue. Then you are to answer this question, identify the unknown in sample B. Thank you for watching, and if this is your first time of coming across my video, feel free to subscribe, like, and comment. Thank you.